All right, so from the last lecture, you basically know that if I have some circle in the xy plane, that circle is going to have some center, let's say at a comma b, and it's going to have some radius, let's say r, and then the equation that describes all the points on that circle is going to be x minus a quantity squared plus y minus b quantity squared equals r squared. So in general, if I gave you an equation like x minus 3 squared plus y plus 4 squared equals 25, you could tell me what the corresponding circle was. You could say the circle is going to have a center at 3 comma negative 4, and it's going to have a radius of 5, just by looking at that equation. So that's quite convenient. But the problem is, sometimes on the SAT, they will give you equations of circles that are not in this standard form. So when we're faced with that sort of situation, we're going to need an algebraic technique to take whatever they gave us that isn't in standard form and put it into standard form so that we can figure out where the circle's center is and where the circle's radius is. Here's an example of what I'm talking about. This is the equation of a circle, x squared plus 4x plus y squared minus 3y equals 4. This is a circle in the xy plane, but it is not in that standard form that we want it to be in. So our job is to try to take the terms that were given here and somehow convert them into this form, x minus a squared, y minus b squared, and then on the other side, r squared. Now the way we do that is by using a process called completing the square. And generally speaking, at first, this process seems very strange. So you're just going to have to trust me at first, follow the process, and then over time, you're going to see why we use what we use. So what we do is we start out with a given equation, and let me just copy the first part, so x squared plus 4x, but then we take a look at the b term on the x's. So in this case, it's that positive 4 on the x. And we divide that by 2, we square the result, and add it to both sides. So we're going to take 4, positive 4, divided by 2, square the result, and then we're going to add that to the left-hand side, and let me just complete the left-hand side, plus y squared minus 3y. And then we're going to add the same thing, so plus 4 over 2 quantity squared, to the right-hand side. Now, it might not make any sense that we chose this particular value, 4 over 2 quantity squared, like why did we add that to both sides? But you should be able to agree with me that it's legal to do what I did, right? I can add 4 over 2 quantity squared to both sides, all right? So once I've done that, I can do a little simplification and think about factoring this x squared plus 4x plus 4 over 2 squared term. It might be easiest for you at first if you just write that as x squared plus 4x plus 4 divided by 2 is 2, 2 squared is 4, and then just thought about factoring that term. You need two numbers that add to equal 4 and multiply to equal 4. So we'd have x plus something and x plus something, and you've probably thought of it by now. The two numbers would be 2 and 2. So you see, it seems like we really lucked out here. We got x plus 2 times x plus 2, which is just x plus 2 squared. That's the sort of form that we're looking for, all right? So it worked out. Adding this 4 over 2 squared thing turned out to get us this perfect square that we were looking for. So that's kind of nice. How about we follow the same pattern for the y's here? So let's go ahead. We have plus y squared minus 3y, and then we want to add to both sides negative 3 over 2 quantity squared. Okay, so that needs to equal 4 plus 4 over 2 squared, and then we need to add that negative 3 over 2 quantity squared. Now again, we'll go ahead and we'll bracket the y's, and we will try to factor them. We need two terms that add to equal negative 3 and multiply to equal negative 3 halves squared. Now if you think about this for a minute, half of negative 3 plus half of negative 3 adds to equal negative 3. Meanwhile, half of negative 3, that's negative 3 halves, times negative 3 halves is the definition of negative 3 halves squared. So I say you can actually fill these two slots with minus 3 halves and minus 3 halves. And if you doubt me on this, just pause the video and try it out. Half of negative 3 plus half of negative 3, that adds to negative 3, and then go ahead and multiply these two, negative 3 halves times negative 3 halves. What does that become? Well, that is the definition of negative 3 halves squared. So now you might be starting to understand why I picked this particular b over 2 squared term in the first place. It's because in general, if I had something of the form like y squared plus by, and then I added b over 2 squared, I would be able to just fill in when I try to do the factoring, I would just be able to fill this in as y plus b over 2 times y plus b over 2. Because these two terms, half of b plus half of b plus half of b, they'll add to equal b, and b over 2 times b over 2 is the definition of b over 2 squared. Now, it's okay if you don't understand that 100%. I hope you understand it at least 90%. But it's okay if you don't understand it 100%, as long as you remember that b over 2 squared, that's half of the term associated with the y, or if you're doing the x's associated with the x, half of that coefficient squared, that's the magic number to add. As long as you remember that, you'll be okay. And you'll be able to do it quickly if you also remember that when it comes time to do that factoring, you can always just go ahead and fill the two empty slots using whatever your b over 2 term is. So let's just go ahead and erase this extraneous, this extra stuff here, and get back to the problem we were doing. We saw by completing the square, we saw that the y's could factor into just y minus 3 halves quantity squared. We already did the x's up here, so x plus 2 quantity squared is what we got out of the x's. And then we still need to simplify the right-hand side. We have 4 plus 4 over 2 squared plus negative 3 over 2 squared. So to simplify that a little bit, 4 over 2 is just 2. 2 squared is 4, so we're going to have 4 plus 4. And then negative 3 halves times negative 3 halves, that's just square the top and square the bottom. So that means you'll have 9 on the top, 4 on the bottom. So this is turning into 8 plus 9 fourths. And then if I want to add these two fractions, I'll need to put the 8 over 4, so that'll be 32 over 4. That's equal to 8 plus 9 over 4. So that comes to 32 plus 9 is going to be 41 over 4 on the right-hand side. So all our work here is finally coming up with a complete solution. We have x plus 2 quantity squared plus y minus 3 halves quantity squared equals the square root of 41 over 2 quantity squared. I just took the square root of this guy here and then squared the result. And this pretty much fits the form. You should be able at this point to know that the center is going to be at negative 2, comma 3 halves, and the radius is going to be equal to the square root of 41 over 2. So how would we apply this on an SAT problem? We are given an equation, and just like before, it's kind of a messy thing. It's not in the neat standard form. And it says the equation of a circle in the xy plane is shown above. All right, so this is the equation of a circle. Which of the following is an equivalent form of the equation in which the radius of the circle, is displayed as a constant or coefficient? So that's just a really fancy way of saying, get me something that is the standard form of this circle equation, or at the very least, something that has the radius on the right-hand side in some way that we can identify what it is. So we take this non-standard equation and put it into standard form. I have x squared, and I'm going to go ahead and I'm going to put the x's over here together. So it's going to be x squared minus 4x, and then y squared plus 2y, and that's equal to 13. Then I need to add the b over 2 term to both sides for both the x's and the y's. So I'm going to do that. I have x squared minus 4x, and then plus negative 4 over 2 quantity squared, plus y squared plus 2y, and then 2 over 2 quantity squared. And then, of course, I have to remember to add those to the 13 on the right-hand side. So that's going to be plus negative 4 over 2 quantity squared, and plus 2 over 2 quantity squared. Now I need to do my two factorings. So I'll start with the x's. I need two numbers that add to equal negative 4 and multiply to equal negative 4 halves squared. And of course, as always, that's just going to be filled nicely by negative 4 halves. So x minus 4 halves, those are going to work out. And by the way, if you don't understand that, go ahead and check it out, that it does actually work. And then for the y's, let's see here, it's going to be y and y. What's going to fill the slots? Again, it's the 2 over 2, so plus 2 over 2 is just 1, so I'm just going to write plus 1 for both of those. And on the right-hand side, we're going to have 13 plus negative 4 over 2 is just negative 2. Squaring that gives me 4, and then 2 over 2 is just 1. Squaring that gives me 1 still. So I have this pretty much done here. Let me just write them as squares. X minus 4 over 2, x minus 4 over 2, that can just be written as x minus 2 quantity squared. And then for the y's, again, y plus 1 is just y plus 1 quantity squared. And then that's equal to 13 plus 4 plus 1, that's equal to 18. So this is almost in standard form. We could identify the center. It's going to be at x equals 2 and y equals negative 1. And then if we want to find the radius, we'd have to take the square root of the right-hand side. So let's do that quick. The square root of 18 is going to be equal to, well, we can't find what it is exactly, but we can simplify by rewriting it as the square root of 9 times 2, then breaking on the multiply under the root. So square root of 9 times square root of 2. And then evaluating root 9, that's 3, so 3 times the square root of 2. That would be our radius. So if we go back to our answer choices over here, we need the radius of the circle displayed as a constant or coefficient. We know the radius of the circle is 3 times the square root of 2, so my eye is automatically drawn to either answer B or C. And I notice that answer C fits what I have here pretty much perfectly. It has an x minus 2 squared and a y plus 1 squared, and then the radius r, 3 root 2 squared. And of course, 3 root 2 squared is the same thing as 18, because 3 root 2 is just the square root of 18. So I would pick answer choice C. Now there's just one more thing that I need to mention when it comes to completing the square for circles in the xy plane. Once in a while you might get a problem that looks kind of like this one. In the xy plane, the graph of this fancy thing is a circle. What is the radius of the circle? Well, we would think, okay, well, let's go ahead and kind of put it into standard form. We'd write 2x squared plus 2x, and then plus 2y squared plus 8y is equal to 5, and that would indeed be a good start. But there's one little kind of asterisk warning here, which is that the completing the square technique we learned does not allow for a coefficient on the x squared or on the y squared that is not equal to 1. Because the technique that we learned, remember, when we come down to factoring it, we need two things, we said, that added to equal the b term and multiplied to equal the c term that we had added. And that factoring technique requires that what's hanging out on the x squared is just 1. You can't have a non-1 term on the x squared in order to apply that technique. So you got to remember just kind of one more thing here, which is when you're completing the square, when you're using that process, before you can begin the process, before you can add that b over 2 quantity squared term to both sides, you have to make sure that the coefficients on the x squared and the y squared terms are only equal to 1. So what that means is you'd have to start this problem by dividing both sides of the equation by 2. So you divide both sides by 2, and that would give you x squared plus x plus y squared plus 4y, dividing every one of those coefficients by 2, equals 5 over 2. And now at this point, because the coefficient on the x squared and y squared terms are 1, all of the logic involved in completing a square is going to work out, and you can just go ahead and do it like we did the previous problem.